SPAs and hot tubs are typically connected to ground fault circuit interrupter protection. According to the National Electrical Code, bonding is not explicitly required at the equipment itself. However, since it is a listed device and ground fault circuit interrupter protection is mandatory, it's recommended to bond it at the panel, in accordance with National Electrical Code Section 250.146 equipment grounding. This process involves connecting a conductor to the ground bar within the panel and then attaching it to a lug on the equipment. While a bolt could technically suffice, a lug is typically provided on the motor, chassis, or frame of the equipment for this purpose. This ensures a direct path for fault current back to the source, enhancing safety and minimizing the risk of electrical shock. The equipment grounding conductor plays a crucial role in the ground fault circuit interrupter protection system. In the event of a ground fault, where current unintentionally flows to ground, the equipment grounding conductor provides a low impedance path for the fault current to return to the source. This allows the ground fault circuit interrupter to quickly detect the imbalance in current between the ungrounded conductor, also known as the hot wire, and the grounded conductor, also known as the neutral wire, and trip the circuit, interrupting the flow of electricity. The National Electrical Code provides specific guidelines for the size and installation of equipment grounding conductors based on the rating of the overcurrent protective device in the circuit. It is essential to adhere to these guidelines to ensure that the equipment grounding conductor is capable of safely carrying the maximum potential fault current. In addition to bonding at the panel, it's important to ensure that all metallic components of the hot tub or SPA are also properly bonded together. This includes the metal frame, pump housings, and any other conductive parts that could become energized in the event of a fault. Bonding these components creates an equipotential plane, minimizing the voltage difference between them and reducing the risk of electric shock. The National Electrical Code requires that a solid copper bonding conductor of at least number 8 American wire gauge be used for bonding the metallic components of a hot tub or SPA. This conductor should be connected to each component using approved bonding connectors or lugs. It's also important to ensure that the bonding conductor is protected from physical damage and corrosion. While the National Electrical Code does not explicitly require bonding at the equipment for hot tub air blowers, local codes or regulations may have additional requirements. It's always a good practice to check with the local authority having jurisdiction to ensure compliance with all applicable codes and standards. Moreover, even if bonding is not strictly required, it can still provide an extra layer of safety and peace of mind. Bonding the air blower can help to minimize the risk of electrical shock, especially in wet or damp environments. The importance of proper grounding and bonding in electrical systems cannot be overstated. These practices are essential for protecting people from electric shock, preventing fires, and ensuring the reliable operation of electrical equipment. The National Electrical Code provides comprehensive guidelines for grounding and bonding, and it is crucial for electricians and other electrical professionals to be familiar with these requirements. In addition to following the National Electrical Code, it's also important to use high-quality materials and workmanship when installing and maintaining electrical systems. This includes using properly sized conductors, making secure connections, and protecting wiring from damage. Regular inspections and testing can also help to identify potential problems before they become serious hazards. When working with electricity, it's always best to err on the side of caution. If there is any doubt about the proper way to install or maintain an electrical system, it's always best to consult with a qualified electrician. Remember that electricity can be dangerous, and it's important to take all necessary precautions to protect yourself and others from harm. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer for specific recommendations regarding your electrical system. Grounding ensures a path for fault currents tripping breakers quickly. Bonding connects metallic parts, minimizing voltage differences. Using proper grounding and bonding techniques is essential to protect from electrical shock. A ground fault circuit interrupter is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault. It works by monitoring the current flowing through the hot and neutral wires of a circuit. If there is a difference in current between these two wires, it indicates that some of the current is leaking to ground, which could be a sign of a ground fault. The ground fault circuit interrupter is designed to trip the circuit very quickly, typically within a few milliseconds, to prevent electric shock. It is typically installed in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. The National Electrical Code requires ground fault circuit interrupter protection in these areas to protect people from electric shock. There are two main types of ground fault circuit interrupters: receptacle type and circuit breaker type. Receptacle type ground fault circuit interrupters are installed in place of standard electrical outlets and provide ground fault circuit interrupter protection for that outlet and any other outlets that are wired downstream from it. Circuit breaker type ground fault circuit interrupters are installed in the electrical panel and provide ground fault circuit interrupter protection for the entire circuit. Ground fault circuit interrupters should be tested regularly to ensure that they are working properly. The test button on the ground fault circuit interrupter should be pressed monthly to simulate the ground fault and verify that the circuit breaker trips. If the ground fault circuit interrupter does not trip when the test button is pressed, it should be replaced immediately. Ground fault circuit interrupters are an important safety device that can help to prevent electric shock. They should be installed and maintained properly to ensure that they are providing adequate protection. In addition to ground fault circuit interrupters, there are other safety devices that can help to protect people from electric shock, such as arc fault circuit interrupters and surge protectors. Arc fault circuit interrupters are designed to detect arc faults, which are a type of electrical fault that can cause fires. Surge protectors are designed to protect electronic equipment from damage caused by power surges. It is important to have a comprehensive electrical safety plan in place to protect people and property from electrical hazards. This plan should include regular inspections, maintenance, and testing of electrical equipment, as well as training for employees on electrical safety procedures. By following these safety procedures, we can minimize the risk of electrical accidents and injuries. Electrical safety is a shared responsibility, and we all have a role to play in keeping ourselves and others safe. Always be aware of the potential hazards of electricity and take the necessary precautions to prevent accidents. Remember that electricity can be dangerous, but by following safe practices, we can reduce the risk of injury.